Hello, my name is Clinton Davisson, and my experiment is known as the Davisson-Germer Experiment. The experiment is consisted of projecting electrons towards a piece of nickel metal in a vacuum, when eventually led to help prove the theory of electron diffraction, which later allowed me to win the Nobel Prize in Physics in the year 1937. Let me explain the experiment in a little more detail. We investigated the reflection of electrons on a piece of nickel in a vacuum and measured how intense the reflection of the electrons were at different angles. We got very normal results until one day we overheated one of the pieces of nickel and ran into the same experiments on it. But the results we got were very different. The heating of the nickel caused crystals to form on the nickel, which caused the intensity of electrons at certain angles to increase greatly. We later discovered the different electrons reflection patterns which occurred with different materials. This later helped to create quantum mechanics and proved the de Broglie relation that states that wavelength is equal to Planck's constant divided by momentum. When we first conducted the experiment, we were not trying to discover the evidence of quantum mechanics. We were actually just trying to study the surface of nickel by firing electron beams at a piece of it and tracking where the electrons were being reflected to. By doing this, we thought that we would be able to determine the characteristics of the surface of nickel. The experiment was conducted at Western Electric in New York, which changed to Bell Labs during the years of the experiment. It changed to that name during the years because the ownership was shared between Western Electric and the American Telephone and Telegraph Company. There were many big events going on in the United States while we were conducting our experiment. The 18th and 19th Amendment were both passed during this time, and males and females were starting to become more equal. There were a lot of technological advances, such as the first affordable car made by Ford. The more important thing was the advances in physics during this time period. In 1924, the idea by Louis de Broglie that all matter displays wave-particle duality of photons. This idea is important to me because it relates closely with my experiment. I could never have done this experiment alone. My main partner was Lester German, as most of you know that from the experiment name. However, a few others contributed greatly to the experiment. Firstly, there's Walter Laser. His idea was that the wave-like nature of matter could be investigated by electron scattering experiments, like the wave-like nature of X-rays were investigated by X-ray scattering experiments on crystalline objects. His idea was then told to us by his senior colleague Max Born. The effects of my experiment were explained by Laser's idea. Without this idea, it would have been a lot more work on our part to figure out on our own. Another important person that contributed to the experiment was George Thomas, who did a similar experiment at the same time by firing electrons through a metal film to produce similar diffraction patterns. I feel that my role in the experiment was to pull everyone together to get the best results, but I do think that Germer and I had the same importance in the experiment. Although it was unplanned and our experiment proved to have a large impact on the physics community, because of the experiment, George Thomson and I got awarded the Nobel Prize in Physics in 1937. Also, my partner, Lester Germer, was awarded the Elliott Crescent Medal in 1931. I'm very thankful for all the support we have had because of this experiment. Many people see it as the biggest discovery in physics. They believe this because we were able to support the de Broglie relation, which helped make the wave-like pattern duality hypothesis, which was a huge discovery for quantum theory. Our experiment also helped with the development of the electron microscope, which helped save many lives and discover many new things. I think that scientists in the future will build off of the findings in the experiment to better understand quantum mechanics and hopefully go on and discover more and more amazing things.